Good morning. My name is Justin Mullikin. I work at Plummer Middle School in the Aldine School District in Houston, Texas. And I'm going to show you an alternate method of solving in equations where you have variables on both sides and constants on both sides. We are shooting from Plummer Middle School, so if you hear the announcements go off, we're going to go right through them. We already had one take that was interrupted, so if my principal gets on the loudspeaker, we're going to continue through. I'm going to try to speak loud enough where you can hear me. I had noticed that in equations, my students were getting very confused. First of all, they didn't know which variable we're trying to get rid of. And then once they did figure out which variable to get rid of, there was a lot of messiness of bringing down numbers. Should I keep change and make that plus a -6? They didn't know what to do to get rid of numbers or to bring them down. So there's a lot of confusion about which variable do I work with first, or do I move a constant? Do I change a negative to a positive? So I decided during training to come up with a different method that kept everything lined up, kept variables lined up, and kept constants lined up as well. So I came up with the Mullikin Method, and here's how it works. It's kind of based on the sense of the number line and which direction you're moving in the number line. Am I moving in a positive direction? Am I moving in a negative direction? So the first thing you need to do is you need to take you need to think about these as 2x, and not -6, but 2x and a -6. And -3x and a +4. Think of them as separate terms, as you would say. So I'm going to take the left side and I'm going to put it on top of my fraction, or almost like my proportion. I'm going to take the right side and I'm going to put it on the bottom. So we have 2x and a -6 and -3x and a +4. Then what I'm going to do is I'm always going to go from, the variables are always going to go from the top down to the bottom. The constants are always going to go from the bottom up to the top. So what it's going to look like is I want to figure out how far, or where am I going to go from a +2 to a -3? What direction is that heading? Well, on the number line, you know that if you go from a positive number to a negative number, that's a move in a negative direction. It's moving towards the negatives. In fact, it makes it to the negatives. The second part of what that is, now that I know it's a negative direction going from +2 to -3, is how far did I travel on the number line to go from +2 all the way to -3? Common misconception is they're going to say, oh, that's a movement of 1, because to go from 2 to 3 is 1. But remind them that they've got to get all the way to 0, which is a movement of 2, and then to get to -3, that's another 3, giving us 5. Another thing I tell my students is whenever there's a positive and negative in the Mullikin Method, all you need to do, just like with number sense, is you can add the numbers together. So one's positive, one's negative, we just add them together. 2 and 3 makes 5. So on the bottom, I have a -5. For constants, this time I'm going from a +4 to a -6. Once again, which direction am I heading? I'm going from a positive number to a negative number, and that is a negative move. So I'm going to put a negative on the top. Remember, constants are going up. Once again, how far are we moving to go from +4 to -6? Students are going to say, oh, that's a move of only 2. Remind them, I'm not going from +4 to +6. I'm moving all the way from a positive number to a negative number. Moving from a positive to a negative, or negative to positive, I can just add the numbers. 6 and 4 is 10. So now I have it set up as -10 divided by -5. The great thing about this method is once you get done with this first step, all you have to do is do the division. If you've got the calculator right there, you can put it right into the calculator, or you can have the students do it by hand. -10 divided by -5 gives us an answer of 2. And of course, you can have them substitute it back in to the equation. 2x minus 6, so 2 times 2 would be 4. 4 minus 6 would be -2. 2 times -3 would be -6. -6 plus 4 is -2, and they match up. But remember, the key to this is, and I'm going to show you 2 more examples, the key to this is to make sure that you always go down with the variables and that you always go up with the constants, because that allows students to only have to do one method here at the end. The reason this works is because variables, we're always dividing by the coefficient at the end of a problem. When we get to the very last stage, you're always going to have a coefficient in front of your variable equaling another constant. So that's why this method works, of having the number that we want to divide by, the coefficient, being on the bottom. Okay? I'm going to take you over to another one, 5x minus 3 and 7x minus 7. Okay? Do the same thing with this problem. First step is to go ahead and put the 5x minus 3, or as we're going to say in the Mullikin Method, 5x and a negative 3. And the right side is going to go on the bottom, 7x and a negative 7. As you can see, this time we're traveling and we're not going from positive to negative. This time we're staying strictly positive to positive and negative to negative. But this is where you got to make sure that you have clarification with the students. So the first part is pretty straightforward. I'm going from 5, positive 5, to positive 7. That's a move in a positive direction. My number is getting bigger. So I can put a positive. And this time, I'm figuring out how far is it from positive 5 to positive 7. Students should be able to tell you that's a move of just 2. And you can even see 5 plus 2 does give us 7. On the other side, and this takes some practice for the students who used to, I'm going from a negative 7 to a negative 3. And they'll tell you, Mr. Mullikin, we're in the negative, so it must be a negative number. But remember, if number line sets, if I'm going from a negative 7 to negative 3, I'm heading back towards the positive numbers. So from negative 7 to negative 3, I know that's a positive move. And how far of a move is it? All you got to do is find the difference of these two numbers. When the numbers are both positive or both negative, we just got to find the difference. The difference between 7 and 3 is 4. So once again, if you take a look, 4 divided by 2 is the last step there. I have 4 divided by 2 is going to give me an answer of 2. Okay? You put that back into the equation. 2 goes back into the equation. And you can see that 2 times 5 is 10, minus 3 is 7. 7 times 2 is 14, minus 7 is 7 once again. So it works out with that as far as with going from positive to positive and negative to negative as well. Okay? The last step I'm going to show you is sometimes you're going to get problems where there is variables on both sides, but only a constant on one side. And it works for this type of problem as well. So let's say that instead of having variables on both sides and constants on both sides, this time I have just a variable on the left side here, and I have a variable and a constant on the right side. So we're going to set it up the exact same way with one twist. I'm going to take the left side, put it on top, take the right side, put it on the bottom. And the students might say, well, what can I do? I'm not going from one thing to anything else here. It doesn't make any sense. I'm not going anywhere. But if you tell them that in place, and just like this works with placeholding, if I add 0, I'm really not putting anything new there. I haven't changed the problem at all. So if they ever don't see a constant on either the top or the bottom, all they have to do is replace it with a 0. And now you'll see it works again. Remember, variables always go down. So from 6 to 4, moving down, so that's a negative move. How far of a negative move it is? It's only going from 6 to 4. That's a difference of only 2. Going from 8 now to 0, going up. Now that we put in that 0 to kind of be a placeholder, we are going from 8 to 0. Moving from 8 to 0 is a move in a negative direction. We're moving towards the negative numbers. So it's a negative move. How far of a move is it? It's a negative 8. Going from 8 to 0, you could say 8 minus 0 is still 8. We go through, we go ahead and we do the division, just like before. Negative 8 divided by negative 2 gives us an answer of 4. Okay? Go back and put it into the equation to see if it works. Answer of 4 goes in here. 6 times 4 gives us 24 on the left side. 4 times 4 gives us 16 plus 8 equals 24 on the right side. So like I said, it's just a little bit quicker method. There's less steps that they have to go through. This also keeps all of your numbers in separate spots. Like I said before, when my students are trying to do things and move constants to one side and variables to one side, they get confused and sometimes they end up subtracting variables from constants and constants from variables. So this method just keeps everything lined up. And with some small prodding, you can get them to realize how to either find a difference and just subtract if they're both negative or both positive, or to add the numbers together if one's positive and one's negative. So the general idea, keep constants together in the same spot, keep variables together in the same spot, and it lines up perfectly to divide at the very end. Please leave comments underneath. Any questions that you have, if you want me to show you any different types of equations. I may put out another video to show that it works also with decimals as well. So if you got decimals, it's the exact same concept. We'll work with fractions. I can show you those in a later video, but please leave me comments and tell me what you think of the Mullikin method. Have a good day.